Hello, everyone, and welcome. I'm Karthik, a member of the ICCT's communications team. Thank you so much for attending today's webinar. This webinar is being recorded, and we will send out the recording to all participants sometime next week. Everyone has their microphones on mute. At any point during this webinar, if you have questions, you can write them in the question box in the control panel to the right of your screen. After the presentation, we will have remarks from the panelists, Oscar Delgado, our Center Manager for Fleets, and Aviral, a distinguished fellow at TERI, followed by a Q&A with the audience. Today, we will talk about unlocking fuel efficiency potential in India's heavy-duty vehicles, presented by Aviral Yadav. Aviral is an associate researcher for the ICCT's Electric Vehicles and Heavy Duties program in India. But before going ahead with Aviral's presentation, I would like to introduce Amit Bhatt, the Managing Director of ICCT India, who will share some brief remarks. Go ahead, Amit.
Thanks a lot, Karthik. Good afternoon, good evening, good morning, wherever you are joining from. Very excited to welcome everyone on this very, very exciting webinar that we are going to do today. And the topic is looking at the technology potential along with the cost effectiveness of fuel efficiency technologies. The reason why we thought we'll do this webinar, one, I think, is the fact that as the G20 conversation right now is happening in India, and we have a big event coming in Goa next week, there's a big conversation which is revolving around how do we decarbonize transportation in general. Now, if you look at the emission profile in India, depending on what study you take, transport contributes anywhere between 13 to 50% of overall greenhouse gas emissions in India. Now, within that bucket of 13 to 15%, medium and heavy duty vehicle are almost 65% of the emission. Now, if we remove that from that 65% bucket, buses as well as light duty trucks, then we are really looking at heavy duty trucks and roughly around 40% or 40-45% of emission coming out. Now, we definitely have very ambitious targets to decarbonize the economy as a whole, including the target of net zero by 2070. So the big question is, as we move along this path of decarbonizing our economy, one, what do we do with transport? But more importantly, how do we deal with heavy duty trucks in India? And that's why I think today's discussion will be very, very important. Because as you know, a lot of times when we talk about decarbonized transport, we talk about two-wheelers, we talk about three-wheelers, we talk about buses, and that's where the conversation stops. But if you're not able to decarbonize the heavy-duty vehicle segment, especially trucks, I don't think we can decarbonize road transport in general. So with that as a background, I welcome everyone. Looking forward to this very exciting discussion where we will have a presentation from Aviral, but we also have two experts who will give their insights. And then we have very open and candid conversations with people who are joining this webinar.
Thank you, Karthik and Amit. I hope the screen is visible. So let me start. Good afternoon, ladies and gentlemen. Warm welcome to you all for joining us. We have a good participation number, and it shows the interest that heavy duty vehicles are picking up in terms of decarbonization. So let's start with a good look at this picture. So we are not actually starting at ICCT, we are not starting to work on clean transport in space, at least not yet. But what we see here is a truck carrying India's ambition. And indeed, trucks, which are just 2% of the on-road vehicle and are responsible for 71% of total free transportation in India. So these trucks do carry India's ambition. And that ambition can be of 5 trillion economy or of rising e-commerce. This means that by 2050, we expect that the truck activity can increase by up to 4 times. With these trucks responsible for about 40% of carbon emissions as well as oil consumption from the on-road vehicles, we understand the important role they will play in another kind of ambition. And those ambitions are reaching our net zero goal and also reducing our oil imports, which are touching about 87% dependency. So India is among the 4th largest truck manufacturer, and we have a few targets for decarbonization. Now, why have we done this research? What is the reason behind taking this project? So in the chart, we see other regions which have committed to reducing CO2 emissions from long-haul trucks. We are behind China, Japan, and USA, not only in terms of manufacturing, but also in terms of setting the fuel efficiency targets. We see European Union reaching up to 90% reductions by 2040, and we see United States reaching up to 50% reductions. About 25% reductions are also achieved. We also have proposal for 25% reductions by our neighbor China. Now, with the recent implementation of phase 1 fuel consumption standards, we have taken a step forward towards tackling this challenge. But the question remains, are we truly leveraging the full potential of existing technology to maximize fuel efficiency? Now, over the next 15 minutes, I will brief you over our this latest white paper on heavy duty trucks, and I'll try to answer these questions. What are the technology potential, and are the solutions cost competitive? What kind of benefit do they provide in terms of unit truck as well as to the country? Diving into the methodology of the paper, it's pretty straightforward. We selected a few truck models to study. We evaluated their baseline fuel consumptions using simulations. Thereafter, we modified these baseline trucks with fuel efficient technologies to determine what are the benefits in terms of fuel consumption reduction. We also evaluated cost for fuel efficient technologies based on US EPA estimates. We scaled them to Indian currency and applied the inflation also. With the technology cost and benefits ready, and with some of the assumptions on vehicle life, discount rate, fuel cost, etc., we applied discounted cash flow model to evaluate the economic feasibility of these technologies after grouping them into different technology packages. We also then evaluated the national level impact of these efficient technologies by creating some policy scenarios. Now, taking you a bit ahead into the methodology, how we selected our test vehicles or the 5 vehicles under study. We made sure that we select the most representative vehicle. That's why we started with financial year 2020 and 2021 sales data, and we categorized all those sales as per the BE classification. When BE releases the fuel consumption standards, they have these standard classifications. Then we ranked them based on the sales weighted fuel consumption. We took the 5 most fuel consuming segments based on BE's CSFC equations. Now, from these 5 segments, we selected for each segment, we selected the leading sales model, the top selling model. In case the top selling model was not available for data collection, we then selected the next best available model. The final selected trucks, you can see on the table on right, there are 4 rigid trucks and 1 tractor trailer, covering the wide range of axle configurations as well as gross vehicle weight. The selected trucks directly cover about 8% of our heavy duty trucks market, but the segments that we have covered, they represent 64% of India's truck sales. After this selection of truck, we then move forward to data collection. We installed OBD devices on all these trucks, and these trucks ran for over 10,000 kilometers, and for 2 months we collected all this data, which involved GPS, engine RPM, as well as fuel rate. Now, moving forward, we used this GPS data to create duty cycles, which is a virtual route, and the engine data to calibrate our virtual models. The duty cycles are needed to simulate real world driving. They actually standardize the effect of external conditions so that relative changes in performance and fuel consumption can be studied. Currently in India, we do not have any regulatory cycle for heavy duty vehicles. Instead, what we have is a testing methodology where we run the vehicle at 40 km/h constant speed or 60 km/h constant speed. But this testing methodology fails to capture the transient nature of real world driving. As we see, the real world driving, the speed varies by a lot. It can be seen in the chart above. So that's why we developed custom duty cycles. Now, once the virtual route is developed, our next goal was to develop a virtual vehicle. For that, we used the parameters on tires, vehicle dimensions, gearing ratios from the OEM brochures, and we modeled all the subcomponents in a multi-physics based tool called MSIM from Siemens. Now, once we have the modeled vehicle ready as well as the route ready, we just did a virtual test run and to find out the fuel consumption. Now, as we saw from the slides earlier, we also had collected real world data on fuel consumption. So that we used to calibrate these models, and the calibrated models then provided us the baseline fuel consumption. Now, before we move towards the fuel efficient technologies, let's look at the losses that happen in a vehicle, in a heavy duty truck. From a previous ICCT paper by Oscar Delgado, we see that engines and tire losses that make up about 80% of all the losses. The engine losses are actually due to the thermodynamic limit, but also due to other inefficiencies in operation. The tires have losses because they dissipate energy when the tire sidewall flexes and generates heat during the tire revolution. There are further losses in driveline and due to air resistance and the quick braking and then acceleration. So now we will look at all the technologies which will be targeting these losses. In engines, we see that we can reduce loss by using friction reduction, on-demand accessories. We can optimize the combustion. There are also advanced engine control and after treatment improvement systems. For a bigger engine of tractor trailer, we can use waste heat recovery or bottom Rankine cycle. We see level 4 and level 5 engines achieving 51.2 and 55 peak brake thermal efficiency, but in real world these values will be difficult to achieve. These are currently being used in research trucks under the super truck program in US. When we talk about tires, phasing out the current biased tires will be a priority because biased tires have higher rolling resistance coefficient, which increases the losses. So introducing the radial tires and then further decreasing the rolling resistance can bring the fuel savings. Similarly, we assume some benefits in terms of gear efficiency, dry sump lubrication, and improved lubricants to give us 1% improvement in the driveline efficiency. We also look at the possibility of introducing automated manual transmission, which although might not directly provide fuel efficiency benefit, but can indirectly do so by optimizing gear shifts. We also looked at accessories, that if we electrify the accessories in a truck, it can lead up to 50% reduction in the energy usage. Then aerodynamics also play a not so significant role currently, but as our infrastructure grows, as we have more and more expressways, our truck speeds will increase, and then aerodynamics will also play an important role. And we can improve aerodynamic performance by better tractor trailer integrated design or fitment of few aerodynamic devices. We also look at hybridization and electrification. For hybridization, we developed a truck with complementary traction motor and a battery to recover some of the braking losses. Similarly, for electrification, we totally replaced the IC powertrain with electric motor and battery. So these are the technologies that we are going to explore. Now, taking you forward towards the result, what we have is a cost curve. This cost curve shows a relationship between efficiency and cost that is required to achieve that efficiency. And these whole costs are at a unit truck basis. Currently, the curve we are seeing is for a 12-ton truck. And we have developed similar curves for all our other 4 vehicles. The technologies are combined in form of packages, starting from the most basic ones you can see in the baseline, or the TP1, which stands for technology potential 1, technology package 1, and they go on advancing up to hybridization or electrification. And we see from the curve that as we advances the technology package, the cost increases by much. If we look closely, the technology package 1, 2, and 3, these can be deployed without significant impact on the cost. However, we see a steep increase when we move to technology package 4 and 5 or hybridization. We also see that hybridization cost is somewhat at par with electrification. However, the efficiency benefit in the case of hybridization are very limited, while for electric, they are going up to 80%. This similar kind of finding is also shown in this different curve, which talks about the payback period. Like once we invest in these technologies, how much time will it take to recover based on the fuel savings that these technology provides. The different clusters show us different truck types, a 12-ton, a 16-ton, 28 or 42-ton truck. If we focus on any one truck type, the different scale, different gradient of the gray, they show us the different technology packages. And we see that even the first package, which has just minimum payback period that starts with 14% of the fuel savings. And even the technology package 2, it has about 17%. And up to technology package 3, the payback period is on the lower side. But the payback period takes a jump as we move from technology package 3 to 4. Now, when we are saying technology package 1, what do we mean? So this is actually a 44 technology package 1 contains a 44.8% peak brake thermal efficiency engine, which is currently available. If we go to European markets, these engines are currently available and being deployed. And then we have tires with rolling resistance coefficient of 0.007. This is also achieved. We have seen in newspapers companies like Apollo and Michelin claiming awards for releasing these efficient tires. So technology package 1 is immediately actually deployable. When we compare the hybridization and electrification, we see that hybridization is only providing marginal benefit over the pure ICE truck. Like for a 12-ton truck, it moves from 38% fuel consumption reduction to 41%. While electrification, it's 100%. We do not need actual fuel. What we need is electricity. So decarbonizing the grid, that needs to be taken care of. But at the operator level, there are no carbon emissions and fuel consumption. So this was about the economic feasibility of different packages. The results are similar for all the trucks. Then once we have talked about the unit level performance, let's look at the impact on the overall economy. So for exploring that, we created a policy sandbox. So we created 2 policy levers. First is fuel consumption standards, how the fuel consumption standard stringency will vary in terms of 3 scenarios, like a baseline one where only organic standards are introduced, or a moderate ambition where the stringency as well as the pace of these standards is high. The other policy lever is the battery electric truck sales mandate, which can be seen in the chart below. So the green line shows the highest ambition, in which we reach 30% BET sales by 2030. Now this is ambitious, and this sounds ambitious because yeah, we were exploring what is the best case possible. And then we also have organic BET sales, which is shown by the line in blue. In the chart above, we similarly see the fuel consumption reduction. The blue line shows the baseline ICE improvement, very gradual, while the green line shows that we reach 25% by 2030, by 2025, and 40% fuel consumption reduction by 2030. So the fuel consumption reduction from ICE actually plateaus after 2030 in these cases. Now, what were the results of these policy scenarios? Now, this chart shows us these carbon emissions. The solid lines, they show us they show us the ICE as well as BET as part of the vehicle sales, while the dashed line are only showing us what will happen if we do not have any electric truck sales. Now, one clear understanding from this chart is that without inclusion of BET, we will not be able to change our emission trends from heavy duty trucks, let alone meeting the net zero. The maximum reduction we can get from fuel consumption, improving the fuel consumption of ICE is just 25%. While having both these policy levers of fuel consumption standards as well as for battery electric truck sales mandate, we can change the trajectory of heavy duty vehicle emissions as early as 2032. Other impact that we saw was on oil consumption. Now this chart shows that by 2070, under the high ambition scenarios, we can totally get rid of the oil imports, and actually there will not be any oil consumption because we will have so many number of vehicles electrified. So these are the findings on the heavy duty truck sector specific. And then if we talk about the overall economy, like the overall oil demand of the country, we will have 2% reduction by 2030. But because these vehicles keeps on adding, so we will have more benefits as we reach 2050. We will get 22% reduction in our country's oil demand by 2050. So these were the analysis, and now I'll finish with some of the key results. In near term, we see the technology package 1 is totally achievable. It will provide us fuel consumption reduction up to 21%, and these technologies are already available. Beyond 2025, we can get fuel consumption reduction up to 31% with next generation engine, some improvement in transmission, along with lower rolling resistance coefficient tires. In the long term, although the 55% peak brake thermal efficiency engine is theoretical, we have assumed that what is the best case possible. So we understand that the efficiency or the fuel consumption reduction will plateau at 45% for the ICE, and thereafter we will have to shift to BETs. Actually, when we looked at the cost curve, we understood that after technology package 3, although improvement is possible for ICE trucks, but it becomes better to invest towards the electric trucks because they will provide more economic as well as environmental benefits. So this is one of our findings on trucks. Then in terms of economy, from heavy duty sector, we can reduce about 84% of oil demand by 2050 and 100% by 2070. So these were the findings, and this paper is just an addition in a long line of research that has been ongoing on heavy duty sector in India by ICCT. There are more papers to come on total cost of ownership as well as life cycle analysis, and we hope that by all this research we will be able to shape the decarbonization of heavy duty sector in India. Thank you. Back to you, Karthik.
Thank you, Aviral, for that excellent presentation and for raising some pertinent points. Now we will move on to the next part of this webinar and listen to some remarks from the panelists, followed by a Q&A with the audience. Remember, if you have any questions, write them in the question box in the control panel to the right of your screen, and we will answer as many as possible. Our panelists today are Mr. Oscar Delgado and Mr. Aviral. Mr. Rao is a distinguished fellow with the Transport and Urban Governance Division of TERI. With his expertise in the Indian automotive regulation formulation and an experience of over 36 years, Mr. Rao has also served as a member of the expert advisory group in the Ministry of Road Transport and Highways. Oscar Delgado leads ICCT's Latin America team and manages a commercial fleet center. Oscar has over 10 years of experience working in the technology and policy topics around heavy-duty vehicles. He's worked with the policymakers in the United States, the European Union, China, India, and Latin America. I will now request Oscar and Mr. Rao to share some insights on this vital issue.
Thanks a lot, Karthik. Maybe I'll first request Mr. Rao to share some initial remarks based on what you saw in
Thank you, Amit. Thank you, and thanks for calling me to be part of this webinar. And I would like to congratulate Mr. Aviral and ICCT team for coming out with such great study on a subject which is very, very crucial for India in years to come. India being still a developing country, I think our need for transportation of both the goods and people is going to increase in years to come, and so we cannot avoid the use of various modes of transport to fulfill these requirements. Having said that, as government has been talking about and pushing electrification of mobility to contain the outflow of foreign exchange for crude imports and also reduce CO2 and also roadside emissions from tailpipe. It's very, very important for us to work on continuous improvement of vehicle performance to reduce both CO2 emissions and also other pollutants coming from the tailpipes. As mentioned by Aviral, the first phase of fuel efficiency norms for heavy duty vehicles have been just implemented. It took very long time for the industry and the BEE and other authorities to come to a conclusion to finalize the basic targets for the phase 1 of fuel efficiency norms for heavy duty vehicles, and this is based on a steady speed testing. And as Aviral rightly mentioned, unless you have a sort of driving cycle which to some level represents the actual usage of these vehicles on the roads, steady speed fuel efficiency may not really indicate how the vehicle would behave on the road. Fortunately, TERI has been asked by BE to work on the next phase of fuel efficiency norms for heavy duty vehicles, and we are also being supported by ICCT and ICCT in achieving this particular completing these projects. So here, the study clearly spells out what are the various possibilities in terms of engine improvements and also other technologies which are available. My quick observation on a couple of things. What Aviral mentioned is one, he's talking about technology which is readily available in Europe and US, but I am not very sure what is the gap between the engines which are being used by Indian OEMs for heavy-duty trucks and how difficult or how easy it is for them to transit to the new, the Indian technology what Europe is using at this juncture for heavy duty trucks. Second point I had, observation I had was the improvements through aerodynamics. Actually, unfortunately, in India, heavy duty truck manufacturers don't make the bodies. They actually sell the chassis. So most of the body work is done by different body builders. And I am not very clear how we are going to ensure that the body is being built is of same design, or is good from aerodynamics point of view. That's a thing, because even standardization of bodybuilding itself has still not been successfully implemented because of various reasons. Yes, implementation of radial tires should happen. So I had brief chat with some tire manufacturers and OEMs. The biggest concern they have is about the cost of tires, and then second thing is the loading capacity in comparison with bias splice. And the other major issue is the road condition where the vehicles get driven. So, and I'm also surprised about what Aviral mentioned regarding the fuel efficiency improvements, what they observed with HDVs. I agree that on highways, the braking would be less frequent. But in spite of that, if hybrids are properly tuned, even steady speeds also, they should give an improvement compared to a bare IC vehicle when there is a hybrid system on the vehicle. I'm only giving observation. We need to exactly understand what do we mean by HEV, what Aviral has mentioned, what I am talking about. I'm coming from the performance improvements, what I have understood from various manufacturers for HEV strong hybrids, what they have launched recently, and the breakup of fuel efficiency, what they are getting in both city drive and also the highways. The last point I have is you have considered battery, full electric vehicles, but why not fuel cell? I think we can go for further discussion. Mr. Oscar may give his comments.
Thanks a lot, Mr. Rao, for these wonderful comments, especially a couple of points that you highlighted. One being the technology gap between Europe and India, the whole issue of aerodynamics that you mentioned. You also talked about radial tire, the cost versus loading, and then this very interesting comment that you made on hybrids and the fuel efficiency as well as the fuel cell. So before I go to Aviral, maybe I'll first ask Oscar to give his opening remarks, and if you could address some of these points, and then we'll take the conversation forward.
Yeah.
Great. Thank you, Amit. So yeah, I guess I wanted to start with describing the challenge that is huge for India. So the largest population in the world and growing, emissions are going to multiply by 4 without policy intervention, and the target is net zero in 2070. So adding to this, there is dependency on oil imports, as Aviral mentioned, above 85%. A huge challenge ahead. The turnover of the heavy-duty vehicle fleet is very slow. We have very old trucks out there. So there is this sense of urgency. We need to act boldly and fast on internal combustion engine vehicles for sure. But as the scenarios that we run show, internal combustion engine efficiency won't be enough to change the trend of increasing emissions. So we need zero emission vehicles, battery electric vehicles, and fuel cells that we failed to cover in this analysis. Good suggestion. We are doing. We're going to do follow-ups on that. We need zero emission vehicles to change the direction of the trend. Let's say there is a lot of work to be done, but we could take a look at other markets that are ahead in terms of energy efficiency standards and electrification policies. Let's say another let's say issue that we have in India is that logistics costs are high compared to those markets. So while other markets progress, the gap is going to increase, and that is a serious concern because that makes India less competitive. India wants to be an industrial powerhouse, is striving for, let's say, for economic growth and industrial development, and the heavy-duty trucks are the heart of the industry. So fuel consumption standards we see for heavy-duty vehicles, we see as a huge opportunity to really enhance the overall competitiveness of India via energy security, reduction of costs, and the opportunity to develop new technologies and their own industry. Ride this wave of the transition to electrification and new energy and become like an industrial powerhouse. So yeah, the other point that I wanted to touch is like the OEMs need, let's say, they don't need usually oppose standards, but they need the regulatory certainty and the market signal that the standards provide for them to make the necessary investments to create these more efficient vehicles. So what we are seeing in other markets is that the standards really help to level the playing field and send that regulatory signal that forces, let's say, that push the investments to generate these technologies and grow these markets. I second Mr. Rao comment on the test methodology. The test methodology matters a lot, and the fuel consumption via constant speed test is kind of an ill-posed methodology from my perspective, at least. It doesn't fully capture the effect of efficiency technologies. Yeah, we need to think of something else to measure it. And we could take a look at the other markets, large markets that have fuel efficiency standards. So yeah, I'll stop there to make more room for the discussion that I imagine is going to come with very interesting questions.
Thanks a lot.
Aviral, before you respond, I have one more query actually. You had mentioned the improvement percentages for various engine improvements, hybrids and electric vehicles. I can understand in terms of how it's improving the kilometers per liter of travel in case of IC vehicles, including HDVs. But in case of electric vehicle, what is the measure you have considered? How do you rate so much improvement?
Sure.
You understood what I am asking you?
Yeah. So we usually for electric, we measure in kilowatt hour per mile, and that's how like we see the energy consumption, and that's how we compare.
So basically, is the energy efficiency improvement?
Yes.
A sort of energy efficiency you are talking about.
Yes. And
okay.
To keep the measure same, we also convert the liters per 100 kilometers or the fuel consumption values to actually kilowatt hour per mile. So everything in now, yeah, responding to some other points. So firstly, on the technology gap between European trucks, engines, and India. So in our research, when we started this, because we were facing a lot of technologies on these markets, China and US, and also EU. So we kind of saw what are the differences. And with Europe, it is not much. They are maybe one step ahead in terms of efficiency, but technology wise, we are at BS6, and Europe will be shifting to Euro 7, but our BS6 engines are at par with what Euro 6 engines were. So there is not much gap in terms of technologies. The gap is there in terms of sizing. So for a same 16-ton or a 28-ton or a 55-ton tractor trailer, other markets will use a larger engines.
Bigger, yeah.
While
Yes.
yeah, in India we will just squeeze the power out of the smaller one. So yeah, so that is on the good side, because other markets talk about engine downsizing, while we already have that. So that is one thing. Next, moving to the fuel cell part. So this study, yeah, it started way back about 1.5 or 2 years back. And if we follow the fuel cell development in the heavy duty sector, everything has kind of come together in the last 1 year, if I extend back. Otherwise, let's say 7-8 months. So that's why we failed to include this. We were not envisioning that that a fuel cell will play a major role in the near term, but yeah, in our other further revisions we will include this. And good news is that in our other studies, like the total cost of ownership, which my colleague Harsimran is leading, and in the life cycle analysis, we are actually comparing hydrogen fuel cell and the other powertrains also. So yeah, that's on the fuel cell. Now on the aerodynamics part, yes, for the rigid truck, that's a problem, because the body building is done at a different, so we need some kind of regulation so that these devices or the aerodynamic improvement can be done. But as our economy matures, so firstly we will be shifting more and more to containerized trucks. So tractor trailers will be more in use because they are more cost effective in terms of logistics. So, and they are being made at the manufacturer level. So, and those are the vehicles which require the aerodynamic improvement most. So I think that will actually take care of itself, because the tractor trailer OEM is responsible. They will kind of integrate the design. So, but yeah, for rigid trucks, if we need to work on aerodynamics, we need some kind of policy making on that one. On the rolling resistance improvement and the triangle between safety and rolling resistance, and the other thing on the comfort and the durability. So yes, as we move towards expressways and our road conditions improve, the larger logistics companies can shift to these expensive tires to get more benefit. But the tires which are getting operated at mines or other difficult pavements, those can continue to be they can transition a bit later. And also the number of those tires or the vehicles is relatively less than what operates on a good highway and expressways. And this will be more true as we move forward into future. So these were some reflections. Did I miss some of your questions?
I think you covered, Aviral. We'll take some more questions, which is coming. So some I've got on the chat box. Some of them are addressed to you, but interesting, some questions are also addressed to Mr. Rao and Oscar. So let me take one by one. But since I am moderating it, I have the privilege to ask my question first. So here's my question. Aviral, as you know, recently we heard Mr. Gadkari talking about air-conditioned cabins for trucks. So simple question, will that impact fuel consumption? And if so, what are we looking at in terms of the impact on fuel consumption?
Yeah, so the simple answer in the easiest answer is that yes, it will impact. It's an additional load, so definitely the fuel consumption will increase. Now we have seen for buses, we have compared the AC bus with a non-AC bus, and there the fuel consumption was the impact was high. maybe about 12 to 15%.
Aviral, I would like to intervene here. What Mr. Gadkari has talked about is driver cabin air conditioning. Don't mix with air conditioned buses. These two are different issues. What he mentioned was air conditioning the driver cabin so the driver feels comfortable. As a result, the drive, I mean, he would be driving safely. That was his point. So, I mean, don't talk about air conditioned buses.
Yeah, the volume that is different. Yeah, the volume that you're going is
Yes, that's a point. That what we have analyzed till now is buses, and because the volume is at 80 meter cube and all, so the impact is about 15% in that range.
That's right. Even in passenger cars also, I mean, the thumb rule is that the fuel efficiency goes down by 15% when AC is on. But all the fuel efficiency tests are done with AC off for whatever reasons.
Now,
but I would like to respond to your question. When you're talking about a commercial vehicle, driver cabin being air conditioned, the impact, the negative impact on fuel efficiency due to air conditioning would be a very small percentage when you compare with the overall fuel consumption of the truck, because unlike a passenger car, the engine power is much higher compared to the power drawn by the air conditioner. So I mean, then we have to weigh against what is the improvements the driver is going to give us because the cabin is air conditioned. But in any case, to cater the drivers with the cabin conditions which are livable is the minimum what one should do. So from that point of view, I fully agree with what Gadkari is proposing to do. This is under discussion for a very long time. Long time, almost more than 10 years now.
Absolutely. So
yes,
long answer short, the impact will be minimal because we are not air conditioning the entire tractor trailer or truck. We are only air conditioning the driver cabin, and then there will some benefits which will come from an air conditioned cabin because the driver will not drive.
Efficiency of driving, yes, that's right.
Thanks a lot, Mr. Rao and Aviral. So the other question is, this is for Oscar. Oscar, the question is, what are the best practices for developing fuel efficiency standards? Especially, what can we learn from Europe, US, and some of the other countries on how do you go about developing fuel economy standards?
Well, I could stay here an hour answering that question, but I would, let's say, what I liked about the US efficiency standards is that they were very pragmatic. Let's say, one example is, okay, you need to start gathering the baseline before starting to impose stringency on the standards. You need to understand what is the current baseline. And in the US, they were very pragmatic. They tested a few representative vehicles and they came out with the baseline like in a question of a year or so. In the European Union, the process took almost 10 years. It was very delayed, the process. Let's say the regulatory process was more owned by the OEMs than by the regulators, really. So there was like a lot of delays, and it was kind of let's say the regulation currently is excellent. It has really ambitious targets. 90% by 2040, essentially for transit buses is 100% by 2030. So it's in a good place now, but it took a while. So I guess my let's say best practices, I would say, don't aim for perfection, aim for good enough. Don't reinvent the wheel, because there are other standards out there and the vehicle simulation tools out there and testing methodologies out there that we could take on and learn from those. So don't try to reinvent the wheel, and be pragmatic. I guess that would be my first.
Thanks. That's good to know. Aviral, this question is from Ananta, and the question is that does the virtual route that you presented, does it represent any specific route like a highway or city, or how did you select this virtual route in your study?
Yeah, thanks for that question. So for the development of duty cycle, currently we have not separated into that this is the urban trucks duty cycle or this is the highway truck duty cycle. Ideally, when we develop the regulatory cycle, that is how it is done. But for our study, the truck was moving majorly on the highway, while at the pickup of the load and at the drop of the load, it was also moving in the city. So we can say that these are closer to the highway cycle. If we in future develop a highway cycle, it will be more closer to this one. And this is not specific to any route. This is a general one because the truck was traveling on one route on one day, it was traveling on a different route other day, and we kind of took that pattern and to understood and averaged it out and see how the speed is changing with respect to time, and brought all those 2 weeks of driving into let's say 5500 seconds or something like that to get that representative driving. So does that answer the question?
Yeah.
Anand.
Thanks, Aviral. So another question, this is from Sudhir. He has two questions. One is, have you considered any co-effects, impacts of electrification like grid saturation, energy sources, that? And then you mentioned you're not included hybrid vehicles, but have you also done any analysis on biofuels?
Sure. So on the first question, the grid sources and renewable energies penetration and all those were outside the scope of this study. Where we created the boundary was we took the grid emissions over the years. We already at ICCT have a ZEVTEC study which proposes how the grid emissions can pan out in the future for India, and we projected those numbers forward to 2070, and so that gave us the grid emissions. But we have not deep dive into how those grid emissions are coming, what is the share of different renewable energy sources, and yeah, definitely not what are the other co-effects on infrastructure or other. So those will be studies in that will be studied in different research, but currently that was outside of the scope of this study. So this was on the first question on electrification. Then again on biofuels. So yes, India has some vision on biofuels, but we have kept our study limited to diesel powertrains and electric and hybrids. Now hybrid was electric hybrid, but not hybrid fuels. So no, we have not studied biofuels, and ICCT has an own stand given the previous research that we have done on biofuels. So that's why we have not considered. Oscar, do you want to expand on the second question on biofuels?
Not really, Aviral. Nothing else to add.
No, I have a point to make here. I think there is a initiative or proposal to bring in LNG for especially heavy duty vehicles instead of diesel. So maybe whenever you are doing the next round of study, you could consider LNG as a possible alternative.
Surely, yes. We are doing that for our life cycle analysis project.
Okay.
Thanks, Mr. Rao and Aviral. This question is actually maybe Oscar and Mr. Rao can answer. This is basically asking that in capital goods, we know efficiency. So whether you're going to buy a refrigerator or a television, you can see the star label and you can get the efficiency. But the question is that, do we have something similar in Americas where you can, when you're going to buy a truck, you can know the information of how much fuel consumption is there and you can buy a much more efficient trucks. And Shrav, do we have this thing in heavy duty vehicles, the fuel efficiency?
Yeah. Amit, I think compared to other countries, in India, we give much more importance to what is called kitna deta hai, fuel consumption of any vehicle anybody buys. More so in case of heavy duty or commercial vehicles, because it's the basic return for them. I mean, it's a livelihood, and this is the return what they're going to get on whatever investments they are making. So, as a result, fuel efficiency in India is, in my view, much more important, and the customers are more sensitive to the so-called fuel consumption, irrespective of the type of vehicle you are talking about. I mean, all customers give a lot of importance to fuel consumption.
Yeah,
So, but
let me complement.
In public domain, let's say I go to a dealer.
No, sorry, I just wanted to add, at one point of time when the CAFE norms were being evolved in case of passenger cars, there was a proposal in a thought process that we should have star rating on the vehicle. But after a lot of discussions and other things, what was decided was that at the dealerships, at every vehicle being displayed, the comparative performance of that vehicle with all other competing models in that particular segment would be displayed. This was implemented also that time, but current situation I really don't know whether it's continuing or not.
Yeah, let me complement a little bit from the international perspective. Let's say at the component level, we have some efficiency labels, for example, for the tires and I guess there is a labeling regulation in India as well, if I'm not mistaken.
India also is coming out with tire labeling now.
Yeah, where you have ratings A, B, C, D based on energy efficiency. So that's kind of consumer information for them to pick more efficient tires. In terms of truck efficiency, the information is not out there like very transparently. Sometimes you find more information on the passenger vehicle side because the agencies could test each and every passenger vehicle model, and that is usually not possible for heavy duty vehicles. Actually, the state-of-the-art methodology for measuring, labeling, let's say, and creating standards in these large markets has been component testing and vehicle simulation, like the vector methodology in Europe or the GEM methodology in the United States, in which you test separately the components, the tires, the engines, the aerodynamics, and then you use a vehicle simulation software as the one that Aviral used in this study to run a model with those input data in the country-specific cycles and country-specific payloads and come out with a CO2 and fuel consumption measurement or estimation in that case. And that's once that information is made transparent, we then can take a look and see and compare, let's say, brands and models. But yeah, there is room for improvement for sure. We recently analyzed the baseline data from 2019 in Europe. I think that's a really great source of, let's say, information about energy consumption of these trucks. How are they doing? How are the tires doing? How is the aerodynamics doing? How is the engine doing? By the way, there are comparisons there between natural gas vehicles and diesel, natural gas engines and diesel engines. Very, very nice data set that usually is not that transparent in other markets.
Thanks, Officer. Quickly moving on to some more question that has come. Dr. Chetan is asking, in the multi-physics simulation that you mentioned, Aviral, did you also include the driver behavior? I'm assuming not.
No way.
There is a virtual driver, and we have kept his characteristics same. So their driver behavior definitely will impact in real world, but for the virtual simulation, we have to nullify that variation. We have kept it same. So he responds in a similar way. He breaks 1 second before once he sees any obstruction. So those kind of behavior, they have been kept same.
And let me add a little bit to that. The philosophy of the of the component testing and vehicle simulation methodology is exactly that: to keep the driver and the test cycle deterministic. Things that you cannot do in a chassis dynamometer or an in-use on-road test, because the test-to-test variability of driver and conditions are going to is going to be high relatively to the energy consumption savings that a given technology could give you. So if you want to analyze very precisely what a single technology is going to give you in terms of energy consumption, the component testing and vehicle simulation is actually more accurate than doing the actual testing in a chassis dynamometer or in use based on that test-to-test variability.
Thanks, Aviral and Oscar. This question is from Avantika, and the question is, in the 2070 high emission scenario, you mentioned fuel demand as zero. How is it zero? I'm assuming it is zero because everything is electric. Is that right?
Yes. So in the high emission scenario, we reach 100% electrification by 2045, 46. So, and the vehicle life is 15 years. Like the most vehicles survive 15 years. So that leaves us with only electric vehicles.
Okay. Harshit
So,
is asking, what can we use the battery swapping system in? So basically the question is, can we use the battery swapping system in heavy duty vehicles like trucks?
we have seen system for bus, but from our stakeholder interviews, we are understanding that it makes sense only for specific use cases where the downtime is actually very expensive. So when the downtime kind of nullifies the expenses that we need to have in the contact points and other electrical components. So there will be very specific use cases for this because the battery is heavy for these vehicles. So that's my I would say understanding, but yeah, open to Aviral, sirs and Oscars.
No, the swapping actually also helps in optimizing the size of the battery, which indirectly reduces the overall weight. So, I mean, we have to work on how we can optimize these things so that so-called the weight penalty because of bigger battery can be minimized.
Oscar, are you seeing swapping heavy duty vehicle trucks in other parts of the world?
We have seen examples in China for heavy duty vehicles. And yeah, I guess I agree with Avidal's answer that is very context specific. It makes sense in certain for certain applications, but not for all of them. And it has challenges of let's say logistics and coordination and empty miles, and you need standardization if you have more than 2 brands that are going to use the same battery, and you need to have also more batteries because you have the ones in the truck and the ones charging in the respective battery warehouses or whatever the name. So yeah, it's challenging, but it could work in certain contexts.
Fair enough. I think Sudhir has asked the question that all these technology that were presented, what are the kind of, has there been any study on how will they be impacted in future? And again, he mentions that this whole air conditioning, saying that the recent government announcement on mandating air conditioning for driver cabin has created a huge uproar in private sector logistics companies. So I guess what I heard earlier was that this will have not significant impact on fuel consumption, but it will definitely improve the overall operational efficiency because the driver would then be driving in a much better condition as the driver is doing right now. Is that the correct understanding, Mr. Rao? Oscar?
Yeah, it's what you said. Yes. But I'm sure ARI or ICAT would be having some figures to substantiate this actually. Because the subject is under discussion for a very long time, so I'm sure need to check with them.
Okay. This question is from Ishita, and she's asking that, is there any view on externalities of switching to electric for large trucking fleet in India? The question is that going the electric way is absolutely ideal and realistic, but do we have enough research on other technologies like LNG, which are being used in China extensively? Aviral, Oscar?
Okay, touching on LNG, let's say it could help the energy security issues of a given country if the country happens to have a lot of natural gas. If it's importing it, maybe not so much. But if we are talking about climate change and CO2 reductions, LNG is definitely not the solution. We have produced a few studies and blogs on the issue. It doesn't provide carbon savings, or it provides minimum compared to diesel. So it really doesn't tip the scale. Let's say LNG is not a solution for climate change. It could be, let's say, an energy diversification pathway, but it's definitely not a solution for climate change.
Okay. This is a question from Sayali, and she's asking that with increase in vehicle efficiency standard norm, like technologies BS4 to BS6, our air pollution are becoming stringent and decreasing, but the fuel consumption and CO2 is also increasing. So while so basically it takes more energy to clean the emission. So what are your take in terms of how will this impact fuel consumption in general, because the standards are getting much more stringent in terms of what the vehicle can emit or cannot emit?
We need to differentiate emissions standard, like conventional pollutant standards, and greenhouse gas or efficiency or fuel consumption standards are two different animals. These standards that we're referring to and these efficiency technologies are going to reduce CO2 and are going to reduce fuel consumption. The fact that when going from Euro 4 to Euro 6, you have a DPF that maybe is creating some back pressure on the engine that could increase energy consumption, but you have the SCR system that you could also optimize to, let's say, for and other engine changes that you could make to at least have the same efficiency than before. That's another thing. And so we should kind of distinguish between the two. If we're talking about zero emission vehicles like battery electric vehicles, fuel cell vehicles, they don't emit emissions of either type, greenhouse gases or conventional pollutants at the tailpipe. So that's kind of a win-win if you're talking about those two kind of counteracting acts. So yeah, we don't see, let's say, we are talking about in this space, we're talking about efficiency technologies, not emission, conventional pollutants emissions. So we don't see kind of that trade-off.
So this is also
Amit, to put it differently, actually, when somebody is working on emission control for meeting the different stages of emission norms, the its impact on fuel economy will depend upon what they are doing to meet those requirements. Either they are doing engine side improvements to reduce emissions coming out of the engine, or they're going for after treatment. If it's after treatment, and then if there is a particulate filter or something where, as Mr. Oscar said, they would be spending more fuel to clear the back pressure, etc. So you will see a dip in fuel economy.
This question is very interesting. It's come from Neeraj Gupta, and he's asking that HDFE, heavy duty fuel economy by CSFC, has been implemented after long delay of almost 5 years. These implementation regulation do not take into account tires rolling resistance presently. Can you throw some light on the plan on implementation of Bharat Vecto, which will take into account these issues? And is Bharat Vecto possible to be implemented by 2025? because remember, India still has a highest bias tires in the world, 55% in C3 and 88% in the C2 replacement market. Maybe Mr. Rao can throw some insight.
I think actually what I understand is when the steady speed fuel efficiency norms were decided for as a phase 1 of fuel efficiency norms for heavy duty trucks, ARI was given a project to develop vector tool for India, meeting Indian requirements. So I am not actually aware of what is the current status of that project. So once that basic tool is developed by ARI, then the various OEMs will have a feel as to how it works, and they have to do some trials, and then the date for implementation will be decided. So this is in what should I say, work in progress, but I really don't know the exact status of the project right now.
Oscar, I'm assuming the same kind of tool is being used in Europe and US for these kinds of work, right?
I think I didn't grasp the question correctly, but yeah, the same tool is used in the US. Let's say the same type of tool is used in China, US, and the European Union. It's a vehicle simulation tool, physics-based, that is fed with input data coming from component testing of the tires, an engine map, and aerodynamics, or an aerodynamic drag coefficient based on a standardized methodology.
Thanks. So this question is from Andreas, and he's asking that one part is the adoption of new technologies for HDV. But while Aviral, you researched, did you also look or include the emission generated from the energy side in terms of grid on the various scenarios? So the question was that, did you also look at the grid emission while calculating emission from the battery?
Yes, so we included, when we presented, we included well-to-wheel emission. So for electric trucks, that means that grid emissions have been accounted for. We have not gone further than that to see into the different sources, but yeah, we have assigned a number to all the emissions and energy consumption from electric trucks.
Thanks. This question is from Spurti, and the question is, RD tests have become mandatory for cars from April 1st, 2023 in India. Trucks have been exempted as of now. Your comments on the future of truck certification? Anyone? Mr. Rao, Aviral?
I'm not very sure whether the statement is right or wrong, because what I heard was that there's some sort of on-road tests in case of trucks already existing. That's what I heard. I may be wrong, please.
Yeah,
Aviral, you know that?
No, same. So I will get back to this question on the email. We'll first confirm yeah.
Thanks. Again, Neeraj is asking that Niti Aayog has stated the country has a potential to save 300 lakh crore from 2020-2025 by logistics cost. Expecting the Bharat Vector will also realize this ambition. The point taken, Neeraj, we all agree that Bharat Vector tool has to be developed, and we should eventually move to that regime of testing and then looking at fuel efficiency standards. So as Mr. Rao said, work is happening. We don't know the current status, but we expect the tool to be coming out soon.
I just want to add here, it's just not sufficient to have very fuel efficient vehicles to get the best efficiency. Also, the infrastructure, the basic traffic management, etc., play a very vital role in operating the fleet efficiently. That's very, very equally important, or maybe more important than just having the vehicle which is high with a high fuel efficiency. I'm not, saying that the fuel efficiency of the vehicle is not important, but it is important. But having a fuel efficient vehicle, to get best out of the vehicle, you have to have other the traffic, etc., and also driver. I mean, everybody contributes to how efficiently the vehicle performs and how efficiently the whole logistics work.
Absolutely. I think the best out of the fuel efficient vehicle we can only get if we have the entire infrastructure and ecosystem also to support.
Yes. A good vehicle given to a rash driver will totally mess up the fuel efficiency. I mean, there's only one example I'm giving.
So there is question that air conditioned cabin will help reduce air drag resistance, which is otherwise caused by driver driving with window open. So,
yeah,
it's a point for Mr. Gadkari to.
Good point.
Naveen is saying that thanks for the detailed study. The question to Aviral is, how did you arrive at a tire CRR target of 0.005 ton by 2030?
Sure. So first to clarify, this is not a target, and this is something we propose that by 2030 this is possible, and this number is coming based on the developments in India market, the kind of rolling resistance the manufacturers are quoting and displaying, as well as the technology penetration that has happened in Europe. And if we assume some lag of 4 or 5 years, which will continue to little bit decrease, so yeah, these kind of rolling resistance are we can already see in other markets. So why not in 6, 7 years, 8 years? Why won't it be possible in India? So that's how we have assumed that.
Thanks. Shreya has a very interesting question, and the question is: trucks in India are generally overloaded, and that is also a barrier for shifting to battery electric trucks. So the question is, have you analyzed this in your analysis, the overloading, and how will it impact the uptake of battery electric?
Yes, so when we started the modeling, we had our discussion on at what payload should we have all these analysis. And while for Europe, we use usually 75% loading to account for the fully loaded trip and the empty trips. For India, we performed all analysis at 100% loading to account for the empty trip, but also maybe 110 or 125% overloading. So that's how it has been. Firstly, it is part of the study. And the second thing is the gap between efficiency of an electric truck and a diesel truck is huge. 77% efficiency is what the electric truck will give. So even if you load the electric truck, still the efficiency difference will remain. And there is also a phenomena that why do the operators do overloading? Because the operating margins are thin. Now with electric trucks, the operating cost will come down by a lot, so they will have more buffer. So possibly, and they can have more trips. So that's how we think that it should not be a barrier. Overloading should not be a barrier.
Aviral, you are an optimist, huh?
Yes. Yes.
Okay, we have some more questions, so we will expect a quick reply. So this question is from Lalit. What software you use to create virtual truck? Aviral.
Yeah, so we have used MSIM's, we have used Siemens MSIM software. However, it can these kind of analysis can be done on other tools also. Like if you talk about open source, it can be done on Scilab. It can be done on Vecto also. We have Vecto publicly available. So if anybody wants to explore that, they can download and explore that.
Okay. The Sudhir's question is that slightly more philosophical in nature, that can we really implement a developed nation's fuel efficiency methodology for developing nation, considering that we have a very heterogeneous traffic fleet and condition?
Yes, we can.
That was
Yes,
too short.
definitely. Yeah.
How do so when we are having the ambition of reaching somewhere, then we should also follow that path. So that is my view, but yeah, open to reflections.
That's why the tool is not being adopted as it is used in Europe or US. It's being actually modified to meet or suit our Indian usage and driving conditions, road conditions, environment conditions, etc., etc. So that's why it is taking time actually. If you were to adopt directly what is there in Europe, then maybe it would have been simpler. But it's not correct.
Absolutely. I think the idea is how do you customize these parameters to
For
Indian
Indian requirements, yes.
then do it. So it's not just copy paste, but then how do you adopt and contextualize that tool? So that's one. I think the other part which Naveen is asking is that can you talk about the challenges and opportunities for the tire industry, especially for the fuel economy standards work? I think the opportunity is absolutely radial tires. It's a huge opportunity. But again, Mr. Rao, you would like to add something on this?
Generally, from heavy duty vehicles, I think the road is clear. They are all moving towards radial tires. And in general, if I talk about auto industry, then people are going towards low friction tires, basically, to reduce the drag. So improve the efficiency, basically.
Yeah,
But
one point.
it's not just sufficient to have low resistance tires, but accordingly the roads also have to be good. Only then we'll get the benefit.
Okay. Deepak is asking question and a quick response from Aviral is that in your simulation, how did you estimate parameters such as transmission gear ratio, transmission losses, etc.?
Yeah, so this simulation tool is very detailed. We can even model a transmission system in that. We can model engine, pistons, everything. So what we have done is we provide the parameters like between the first and the second gear, what is the gear ratio, and this number we have gotten from OEM manuals. So we searched a lot for that. That is difficult to find, but yeah, that's how it is being done.
Thanks. I think the question of Sanjay on a hydrogen fuel cell, that we will do in the subsequent study that has not been included here. Point well taken. Question from Hugo is that does this study consider CO2 emission during productions of electric trucks? No, we have not included that. That's a separate study that will come sometime soon, and we'll share that with you. So keep looking at.
That's a life cycle study.
Life cycle study, absolutely. Vandela is asking which is the sample size for each TP, just to assess the accuracy. So I'm not sure what the
the technology package. There is no sample size. The only sample size we have is the trucks we have chosen, and other than that, these are the technologies that are already available, and yeah, we have involved them.
So the reduction is probably on a per truck basis, and once you have the fleet, then you can always multiply and get that number. Priyank is asking how overloading impacts fuel efficiency of ICE versus BEV in trucks.
Yeah, this one we covered. So there is a huge gap, and with overloading, that gap remains same, if not less. So an overloaded diesel truck will perform worse, and same with electric truck, but the gap remains.
Aviral, I have one question. When you announce the range that's done at a particular specified load. So with reference to that, if you are overloading by 20%, 30%, how much impact it will have on range? in case of
Yes.
electric vehicles?
So yeah, currently what we have done in this study is kept the gross vehicle weight same. So the addition of the battery for a higher range will not actually lead to a heavier vehicle. It will just have a payload penalty. So that's how we are handling in this study. But the sensitivity analysis on range versus this weight of the battery,
Overload. Yeah, correct.
yeah, that will be done in our this total cost of ownership paper.
No, I am not per se talking about weight of the battery. A given vehicle, you are declaring for a given battery system what is there on the vehicle. You are declaring a particular range, but the operator overloads the vehicle with 20% extra load. So, what is the impact on the range?
No, we have not performed that sensitivity analysis in this
Because
study.
that's going to be very important.
Yeah.
Absolutely, that will be important. I think Yash has mentioned about well-to-wheel. No, this is not included here. That's a separate study that will come out. Sanjay is asking about whether the recording will be available. Absolutely, we'll post the recording in maybe in a week's time. And then the question is mostly on the well-to-wheel analysis. Again, that will come in some time that we are working on. And then the question was that, have you also included in terms of battery replacement cost in the analysis? Aviral, have you considered that?
Yes. So for both this study and others, what we assume is over a lifetime of 15 years, there will be at least 2 replacement for the batteries, considering LFP battery. So yeah.
Which is very conservative, by the way. It's a conservative assumption.
Absolutely. So I think with this, we have broadly covered all the questions that came out.
On that time.
We are almost close to the time, but before we give it to Karthik for formal close, any quick reflections from Oscar, Mr. Rao, and Aviral, and then we'll hand it over to Karthik.
Amit, my only submission is after doing all these studies, I think we should run a pilot to really understand how these proposals really work on ground. Because we make a lot of assumptions and we try to pick these things from other countries where driving conditions, situations are different. So in Indian situation, Indian driving pattern, the road conditions, etc., we need to actually do some pilot to understand exactly how they behave.
Absolutely, fair point, Mr. Rao. Oscar?
Yeah, I guess my closing remark would be around let's focus on the larger picture. Sometimes regulators are, let's say, my task is fuel consumption of internal combustion engine vehicles, and they siloed the analysis on that. And the big picture is that there is a transition to zero emission vehicles that is going globally. India is aiming to become an industrial powerhouse, is starting to have, let's say, incentives to produce batteries locally and to grow, let's say, to really grow that industry. And these standards are really a good opportunity to push for zero emission vehicles. So we know that internal combustion engine vehicles, we need to act now because of the long turnover. Let's say these trucks are operate for many years, but don't miss the opportunity to push for bolder transitions towards zero emission vehicles.
Thanks, Oscar. Any concluding thoughts from you, Aviral?
No, thank you, Oscar and Aviral, sir, for attending, and all the participants. It was a good number. So it's good that people understand the role that heavy duty vehicles and these fuel consumption standards play. And we hope that we takes up some of these findings and will continue to provide high quality research.
Thanks a lot, Aviral. I'll hand it over to Karthik for formally closing the webinar. Over to you, Karthik.
Thank you, Amit, Aviral, Oscar, and Mr. Rao for your insights on this key topic. And with that, this webinar comes to a close. Thank you to everyone for participating in today's presentation. And please don't hesitate to reach out to us if you have any further questions. Remember to follow us at the ICCT. Thanks again, and we hope to see you soon.
Thank you.
Thank you all. Have a nice one.
Thank you very much. Thank you. Bye.